Hello guys, this is Ms. Ponce de Leon again. We're going to go over page 3 of our notes, and this is using inverse operations. Okay, so if you take a look at our notes here, a little bit of vocabulary here at the top. Tips is to solve one-step equation, blank the variable by using blank or opposite operations. Okay, so here our vocab is to solve one-step equations, isolate the variable, isolate means just get the variable by itself. Isolate the variable by using inverse or opposite operations. Okay, so if you remember from junior high, inverse operations are basically just opposites of each other. So if I told you we had addition, then the inverse of addition would be subtraction, and vice versa. If I had multiplication, then the inverse of multiplication would be division. Okay, and then another one that you guys will get more familiar with is another inverse operation. If I have something, a variable x squared, okay, the inverse operation or the opposite operation of squaring something is taking the square root of it. Okay, so these are some basic inverse operations. And just think about them as the opposite. So the opposite of adding something is subtracting it. The opposite of multiplying is dividing. And the opposite of squaring something is taking the square root of it. Okay, so those are just your basic inverse operations. So we use inverse operations to solve equations. Okay, so we're going to work a couple of examples here. So taking a look at question number 1, to isolate that variable, we use inverse operations. So we're trying to get this x over here by itself on question number 1. So if I have a minus 4, I use the inverse. So the opposite or the inverse of minus 4 is a plus 4. So in order to balance that equation, whatever I do to the left side, I have to do to the right side. So the purpose of doing this is to isolate that variable. So my negative 4 or my minus 4 and my plus 4 cancel each other out. I'm left with x over here. And then I use my math. I have a negative 2 and a positive 4. If you need to, think about that number line again. Okay, look, if here's my 0. If I positive 4, 1, 2, 3, 4, and then I subtract 2 from that, go back 2, so here you go, at 2. Okay, so a positive 4 and a negative 2 is a positive 2. So just think of that also as x as a 4 minus 2. Okay, so there's my answer there. Okay, example number 2. Again, I am isolating my variable using my inverse operations. So the inverse of negative 7 is a positive 7. Okay, so let me just, so the opposite of negative 7 is positive 7. So if I, let me erase that, I'm sorry. Erase that here, let's get started again. Sorry about that. So minus 7 inverse is plus 7. Whatever I do to one side, I do to the other side, plus 7. Okay, so now my negative 7 and positive 7 cancel out. I'm left with just n on my left side of the equation. And then 22.5 plus 7, that gives me 29.5. And that's my answer for n. Okay, so just remember, use our inverse operations to isolate that variable. Okay, and then always balance your equation by whatever you do to one side, you do to the other. Okay, so let's take a look at, let's move on to question number 3. Okay, now, if you guys remember from junior high, when you have a variable multiplied by a fraction, you can get rid of that fraction by multiplying by the reciprocal. So over here, I can multiply this left side by a -4/3, which is my reciprocal. Again, whatever I do to one side, I have to do to the other side. So multiply by that -4/3. Okay. Over here, my 4's will cancel. Take a look at this. The reason why I multiply by that reciprocal is so that these numerator and denominators will cancel. Okay, my 4 cancels with my 4. My 3 cancels with my 3. And then my negative times negative becomes positive. And that's going to leave me with just a y by itself on this side. Okay. So now on the right side, I need to multiply this 9 by the same inverse that I did on the left. I'm going to show you, I'm going to make that 9/1, okay? Because I want to show you how when I multiply my fraction, 4/3 or -4/3, I want it to look a little bit simpler there, okay? So now if you remember your operations for multiplying fractions, you multiply straight across the top and multiply straight across the bottom. Okay, so in this case, you have y equals 9 times -4 on top in the numerator, and then 1 times 3 on the bottom. Okay, so that's, again, so 9 times -4 is -36/3, and then -36 divided by 3 should get you -12. So in this answer is y equals -12. Okay, so take a minute to look at that. If you need to pause and rewind the video, go ahead and do so. Okay, otherwise we're going to move on to our next question. So question number 4, again, it's another fraction. In this case, I am trying to isolate that variable b. So if I have a b divided by 4, the best way for me to do that is to use my inverse operations. Divided by 4, the inverse of that is multiply by 4. Whatever I do to one side, I have to do to the other. Okay, so now, reason why I do that, this 4, and this can actually be 4/1 if you want. That 4 cancels with that 4. I'm left with b equals 12 times 4, which is 48. Okay, and that is my answer. Okay, so again, when you're working with fractions, you can either think about it as an inverse operation where our divided by, right here, divided by the inverse is that multiplication, or you can think about it as getting rid of that fraction over here by multiplying by the reciprocal. Okay, so either way, that works for us. Okay, now let's take a look at question number 5. Okay, and guys, at any time if you are confused and you need to go back, just pause the video and rewind. Okay, so now with question number 5, we are again isolating the variable. We have 5.3 times x. So in order to isolate that variable, if that's a multiplication operation, the inverse operation is divided by 5.3. Again, whatever we do to one side, we have to do to the other side, 5.3. Okay, so in this case, we have 5.3x divided by 5.3 is x. 15.9 divided by 5.3, I know that that is 3. Okay, so that's x equals to 3. If you do not have a calculator and you do not know that off the top of your head, you need to go ahead and do that long division. 15.5 divided by 5.3. Remember, move over that decimal, move over that decimal. 53 goes into 159 3 times. That's 9, 15, there you go. Okay. But if we're dealing with whole numbers, you should be able to hopefully see that 15.9 divided by 5.3 is 3. Okay. If you need to pause that and rewind, go ahead and do so. Let's take a look at this next question, number 6. Same thing, we're using our inverse operations. 7 times x, or 7 multiplied by x. The inverse is divide by 7, divide by 7. I'm left with x equals, okay, that's going to be 3 again. Again, if you don't see that, 21.7 divided by 7. Okay, 7 goes into 21 3 times. That's a 21. 7 goes into 7, bring your decimal 1 time. Okay, and that's how we got, oops, I put 3 over here, but that should be 3.1. Sorry about that. Let me erase that. Okay, and it's a good thing I checked my work. Let's see if anybody caught that, but my answer should be x equals 3.1. Sorry about that, guys. Okay, so there we go. We are done with the using inverse operations notes, page 3. If you have any questions, pause, rewind, or send me an email or ask me in class. Thank you so much and have a great day.